Alright, this is the review for the test, which will be on Wednesday when I come back. So from lesson 11, you have to remember how to complete this expression. Or not complete the expression, but complete the square to rewrite the expression. So here's the expression. X squared plus 6x minus 10. And we'll get the blue marker out here to make this a little more visible. And go to there. If I want to rewrite the expression, then I have to group these two together. There is no item other than 1 on the x squared. So I group those two together like this, x squared plus 6x, leave a space, and then keep the minus 10 out there. What do I need to do to fill in that space? What is my first step? Half of 6, and what's half of 6? 3, and what's 3 squared? 9. So if I add 9 inside of these parentheses, and I'm in an expression, which means the whole thing just stays on one thing, on one side, because there's no equal sign. What must I do outside the parentheses? Take away 9, yeah. So I want to go back and write this in the completed square form. So I need my variable x. What sign am I using? The first one plus, and then what do I put down? 3, which is half of the 6, close the quantity and square, and then minus 10 minus 9 comes out to be minus 19. I'm going to complete the square on this problem. Do I have anything other than 1 beside the x squared? No. So I have to group these two together and come up with x squared minus 3x, leave a space, and then plus 4. What is half of 3? 1.5, or I can make it 3 over 2. If I make it 3 over 2, then I square 3 over 2. What is 3 over 2 squared? You square the top, you square the bottom. 9 over 4. So I've added 9 over 4 here. What do I have to do outside of that? Subtract 9 over 4. So I end up with x, and then the sign from the middle, half of 3, which is 3 over 2, square the quantity, and then I have to simplify these fractions out here. I need a common denominator of 4, so I would come up with 16 over 4 minus 9 over 4. 16 minus 9 is 7. And you could even take that down to 1 3/4. So you should have had 1.75 outside of the parentheses. Rewrite by completing the square. What is the difference between in lesson 12 and lesson 11? There is a number here. But we still have to group those two together. So we will do that. And we will have 2x squared plus 6x, leave a space, and then we come up with minus 9. What do I have to do with what's in the parentheses since I have something other than 1 beside the x squared? We have to divide what? Divide everything in the parentheses by what? 2. So we're taking out a 2. 2x squared divided by 2 is x squared, and 6x divided by 2 is 3x. Alright, this takes us back to a problem that looks almost identical to the one we did in lesson 11. We need half of 3. Half of 3 is 3 over 2, and if I square it, I get 9 over 4. But did I add 9 over 4 to this? No, I've added 2 times 9 over 4. 2 times 9 over 4 is 18 over 4. I've added 18 over 4, so I have to subtract 18 over 4 from the outside. So I keep my 2, use the variable, sign from the middle, half of 3, close the quantity and square it, and I have to come up with minus 9 minus 18 out here. So that's really minus 36 over 4 minus 18 over 4. Minus 36 minus 18 is minus 54. And I can reduce that 54 over 4. If I divide them both by 2, I come up with 27 over 2. And if I wanted to put that as a mixed number, 2 goes into 27 13 times with 1 left over. So I'd have 13 and a half, minus 13 and a half on the outside. 3x squared plus 8x plus 12. We have to do the same thing with that. Group these two together. What do I have to divide out of that quantity? I have to take a 3 out. So there goes 3. And I divide 3x squared by 3. I'm left with x squared. 8 divided by 3 is simply 8 over 3. And we keep the x. Now we need half. Half of that. There's 2 different ways you can do it. You can multiply the denominator by 2, or you can divide the numerator by 2. That will cut the fraction in half. Whichever way you want to do it. If you want to divide the numerator in half, you would end up with 4 over 3. If I square 4 over 3, what do I come up with? 16 over 9. If I multiplied the denominator by 2, I would have 8 over 6. And if I squared that, it would be 64 over 36. But I could reduce that down to 16 over 9. So it's probably better to take the numerator in half and then square the new fraction. But I did not add 16 over 9. I've added 3 times 16 over 9. That's 48 over 9. If I added 48 over 9, I have to take away 48 over 9 out here. So put it in the completed square form. You need the x, the sign from the middle, half of the 8 over 3, which is 4 over 3. Close the quantity and square it. And then you have to simplify your fractions. With a common denominator of 9, you would have 108 over 9, and then minus 48 over 9. So 108 minus 48 is going to be 60. 60 over 9 can be reduced. $60 over 9 is the same thing as 20 over 3. And 3 goes into 20 6 times with 2 left over. So 6.3 repeating is what you would have left out there on the right side for your constant if you did it with decimals. Lesson 13. Solve by completing the square. So we still have to complete the square, but now it's an equation, and the difference between this and the expression is now when you add something as the result of taking half of the middle term and squaring it, you're going to do the same thing on the other side. Or if you stay on the same side, then it's going to be the opposite. So that comes into play. You have no other term beside x squared other than 1. So we can write it like this. X squared plus 9x, leave a space, and then you have this 14 there. That 14 is going to have to move over to this side and change signs to negative 14. We want to get it away from the quantity. 9 is our middle term. We need half of 9. If I divide 9 by 2, I just get 9 over 2. If I square 9 over 2, I come up with 81 over 4. If I add 81 over 4 to the left side, I have to add 81 over 4 on the right side. And then simplify this into my completed square form on the left. X plus 9 over 2, close the quantity and square. But I have negative 14 plus 18 over 4 on the right. I need a common denominator of 4. That would be negative 56 over 4 plus 81 over 4. Or you can do it in decimals. I just can't do it both ways up here at the same time. Keep the left side the same. On the right, negative 56 plus 81 is 25. And we still have that over 4. What do I need to do to both sides to get rid of that quantity squared? Square root. So I need the square root of this, square root of that. On the left, I'm left with x plus 9 over 2. On the right, when I find the square root of a fraction, and the top and the bottom are both perfect squares, such as 25 and 4, then I find the square root of the top, square root of the bottom. And remember, it will be plus or minus. The square root of 25 is 5. Square root of 4 is 2. And this sets up having to find two different equations. That would be x plus 9 over 2 equals a positive 5 over 2, or x plus 9 over 2 equals a negative 5 over 2, and solve each one of them. In this case, it would be 5 over 2 minus 9 over 2, which is a negative 4 over 2, gives me an answer of negative 2. On this side, negative 5 over 2 minus 9 over 2. Negative 5 minus 9 is negative 14. Negative 14 over 2 is negative 7. So you have an answer of x equals a negative 2 or x equals a negative 7. Same directions, same type of problem, complete the square in order to solve the equation. But that equation is not in this form, which is ax squared plus bx plus c equals 0. What would I have to do to get that into the proper form? What must move? The 30, is it going to be on the right side? Technically, yes. Yeah, he's right. So we can do that. We don't have to go straight to this form. So we can go here and move that 30 to the right and make it negative 30. Now what must move? Rest of the equation has to go to the left. So that would be x squared minus 11x when you move it all over to the left-hand side. Alright, so we're going to have x squared minus 11x, leave a space, and then over here a negative 30. Half of 11. Half of 11 is simply 11 over 2. And if I square 11 over 2, I get 121 over 4. Whatever I do to the left-hand side, I have to do to the right. And then write it in the completed square form. x minus 11 over 2. That's half of 11. Close the quantity and square. And then we have negative 30 plus 121 over 4. We need a common denominator of 4, so that would give me negative 120 over 4 plus 121 over 4. And I have to combine those fractions. Negative 120 plus 121 is simply 1. So I have a 1/4. Like we said in the last problem, square root of both sides leaves me with x minus 11 over 2 equals plus or minus. The square root of 1 is 1. Square root of 4 is 2. So I have two problems to do. X minus 11 over 2 equals 1/2, and x minus 11 over 2 equals a negative 1/2. Solve each of them. In this case, it's 1/2 plus 11 over 2. 1 plus 11 is 12. Divide it by 2 to get a 6. Over here, it's a negative 1/2 plus 11 over 2. That's going to give me a positive 10 over 2, which is 5. So the answer is x equals 6 or x equals 5. Lesson 14. We want to take out the a, so we would have a times the quantity x squared plus b over a x. Leave a space, and then move the c over and make it minus c. And then complete this from here on out. We have x squared plus b over a x. Half of b over a, remember we could cut the numerator in half or multiply the denominator by 2. I'll multiply the denominator by 2 and come up with b over 2a, and then square that to get b squared over 4a squared. But that's not what I have added. I have done this. A times b squared over 4a squared. So when I do that, I end up with an a b squared over 4a squared. But see, this a is going to be here, and it's going to cancel out with that and that, leaving me with just an a in that spot. So I would end up adding b squared over 4a is all that turns out to be. So if I put this in the proper form, x plus b over 2a, close the quantity and square that and set it equal to negative c plus b squared over 4a. Alright, so we're going to have to get this by itself here, and then on this side we're dividing by a. If I divide by a on that side, it's the same as doing this. Negative c over a, and then plus b squared over 4a squared. You multiply the denominators by a in each case. And then the square root of each side comes out to be x plus b over 2a. And then on this side, we have the square root of this, which is the same thing as the square root of negative c plus b squared. And we're going to have common denominators as well. So if I made this a 4a there, I would have to put 4a on top. like that. And simplify a little bit further if we can. That's the same thing as saying b squared, putting that first, minus 4ac, and then over 4a squared. Alright, so now we want to do this. We want to move what we had, keeping this the same, trying to squeeze it in there, and then put minus b over 2a. You have the square root of this here. Square root of the top, square root of the bottom. Well, the top you can't do much with, so it's just square root of b squared minus 4ac. And on the bottom, you can find the square root of that, it's simply 2a. And then over here we have minus b over 2a. Don't forget we just took a square root, and I'll have to move this equal sign to the left a little bit. So we would have a plus or minus there. If I simply moved this out front, I would have negative b over 2a, and then plus or minus the square root of b squared minus 4ac. All of that over 2a. And then you could finish this off by saying, since these denominators are the same, you would have negative b plus or minus the square root of b squared minus 4ac. All of that over 2a. And that is your quadratic formula. Lesson 15 is this. Solve the quadratic, or solve using the quadratic formula. You can't use the quadratic formula until you put it into this form. ax squared plus bx plus c equals 0. So that means you would have to move your 3x to the left, 3x squared to the left. You already have a 5x. Move the 12 to the left. Change the sign. What is a? Negative 3. What is b? And what is c? Negative 12. Alright, you've got to use your formula, which is negative b plus or minus the square root of b squared minus 4ac. All of that is over 2a. And plug in what you know. We would have a negative 5 plus or minus the square root of 5 squared minus 4 times negative 3 times negative 12. All of that over 2 times a, which is negative 3. And then simplify. You'll have 25, and in here we have minus a negative, 3 negative signs you can think of that as. 2 negative signs gives you a what? A positive. 3 of them will give you what? Negative. So you would have minus 4 times 3, which is 12, and then 12 times 12 is 144. And on the bottom a negative 6. Negative 5 plus or minus the square root of 25 minus 144. 25 minus 144 would be a negative 119. What happens when you have a negative sign under the square root sign? There is no answer, no solution whenever you have a negative discriminant. Don't forget this. Your discriminant is b squared minus 4ac. It's what's under the square root sign. If that is equal to 0, you have one solution. If that is greater than 0, you have 2 solutions. If it's less than 0, you have no solutions. What is the vertex? All you have to do is look at it and figure out what the vertex is. Opposite of this number is 2. Keep this one the same. -3. That is the vertex. Same thing here. Opposite of this number, -4. Keep this one. 9. In this form here, without the parentheses, the first one is always 0, then you keep this one, 6. Same thing with this form, 0, -5. What about when it's just y equals x squared? Do you remember what the vertex is? 0, 0, yeah. Even if you have a number out here to the left of the parentheses, you still do this the same. Opposite of that number is 4, and then keep that number the same. Write an equation using the vertex. So we'll zoom in here so we have a little bit more room. For this one, remember you have to put y equals this. You have a -1. So when you go back to put it in the equation, you end up with +1. Close the quantity and square, and then a +2. In the next one, you have a 6. It's a +6, so it would go in as -6. And then keep the -3 the same. -5, that would go in as +5. -2 stays the same. Same thing here. This would be a -9. Keep the 13 the same. The first one is 0, so that means you don't need parentheses, just an x squared, and then put a +4. Whoops, I put a 0 in this. That's not right, so we'll mark that out. We need an x squared, and then -1. And the last one, 0, 0, is just y equals x squared. At what width and length would a rectangular pen have to be to have a maximum area if you have 200 feet of fencing to use? So we did one like this last week, where you had to come up with an expression for L, and if we start with 200 feet and take away a W, take away another W, that leaves us with just the lengths that are on the rectangle. And if we're left with 2 lengths of the rectangle, we can divide by 2 to come up with just one of them, which is L. And we simplify to get 200 minus 2W, and put that over 2. Our expression would then be simplified, dividing everything by 2. So just 100 minus W would give us L. And our function A of W would equal the length times the width. So we have a width, and we multiply it by the length, 100 minus W, and simplify that to get 100W minus W squared. And reverse the order so we can have the squared term first. And then complete the square. Take out the negative sign, change the sign of the 100W, leave a space, and then complete the square. Half of 100 is 50, square 50 to get 2500. And if I add 2500 in there, remember I've really done net minus 2500, so I would have to do 2500 out here. So negative quantity of W minus 50, close the quantity and squared, and then plus 2500. And from that you can get the vertex. The vertex will be 50 2500. And remember, the 50 is the width and the 2500 is the area. So at a width of 50, you know that in your box, if you had a width of 50 and you started with 200, 200 minus 50 is 100, so you still have 100 left. Divide it by 2, and you would have 50 on the lengths as well. We have to graph this. This is the last thing that we did, so we may not make it all the way through this in the interest of time, just a couple of minutes. But if you want to find your y-intercept, it's at the very end. Should be just a hyphen. Y-intercept equals 12. If you want to find your x-intercepts, you can use the quadratic formula, or you can factor. In this case, this is factorable. X plus 4, x plus 3. Do the opposite of these numbers to get x equals negative 4, x equals negative 3. And to get your vertex, you could complete the square by doing x squared plus 7x, leave a space, and then have plus 12 out there. Half of 7 is 7 over 2. Square it to get 49 over 4. And do minus there. X squared plus 7 over 2, or just x plus 7 over 2, and then square the quantity. And then do the common denominator of 4, so that would be 48 over 4, and then minus 49 over 4. So you're left with x plus 7 halves, square the quantity, and then minus 1 over 4. Your vertex would come out to be minus 7 over 2, and then a minus 1/4.